Okay, so good morning to all of you.
Good morning, sir.
Is my screen visible?
Yes, sir.
Okay. So as you know, we are supposed to start a new unit today, or let us say new part of Unit 2. So we will start that, and the first components which we are going to discuss is pipes. So basically, before going into further details, let me tell you, it is the most important components of the entire water supply scheme. From transmitting the raw water from the source to the treatment plants, and thereby from the treatment plants to the distribution network of transportation of the treated water. All these things are actually done by the help of conduits, which can also be called as pipes. Now conduits are types, I would say. One is gravity conduits and another one is pressure conduits. Now, gravity conduits, the predominant factor by which the water flows is basically the gravity, and in such conduits, the hydraulic gradient line will coincide with the water surface and will be parallel to the bed of the conduit. On the other hand, so we have the pressure conduits. Now in case of pressure conduits, mostly when we say pressure conduits, we tend to talk about pipes, because in pressure conduits, these are the closed conduits, and as such no air can enter into the system, and the water flows under pressure above the atmospheric pressure. Fine. And the hydraulic gradient line for such a conduit can be obtained by joining the water surface elevation in the piezometers installed in the conduits at various places. So that's the main difference, between your pressure conduits or pressure pipes and the gravity conduits. So when we say pressure conduits, we try to talk about pipes. Now pipes, as I mentioned, most important components, and since it is pressured conduits, that means it will have more pressure than the atmospheric pressure. That is why we need to ensure about the material and the stability of these components. And since water is under pressure always, hence the pipe material and the fixtures should withstand the stress due to the internal pressure, vacuum pressure, and when the pipes are empty, water hammer when the valves are closed, and temperature stresses. So these are the different type of trace which can get generated during the operational period of a certain pipes, which needs to be taken care in the beginning itself, and accordingly considering all these stresses and pressures which a pipe can exert throughout its life cycle should be considered in the design. So before going into the design aspects, let me talk about the requirements of a pipe material. Now, any material should not be used to produce pipes. So there are certain characteristics which need to consider to call a particular material very much suitable for the pipe material. So it should be capable of withstanding internal and external stresses. That's the most important part, which I mentioned earlier as well. And the joining characteristics should be easy, so we should use a material which where we can have easy joints, and we can easily change the direction of that particular pipes by putting all these joints. So it should have facility of easy joints. Now another one important thing is size. So when you are transporting, depending upon the amount of water and the number of users, you can sometimes reduce the size. So the pipe material should be available for all the different sizes which you are planning for, and for transporting as well as for erection of the pipes. And since we are talking about a design period of 30 years, so the material has to be durable, obviously. And another one thing is it has to be inert, completely inert. There should not be even slight reactions with the water components of the minerals which are getting carried by the water. So there should not be any change or alteration in the quality. If you transport the water from the treatment plant to the consumption point, so if you measure the water quality in point A, and then if you measure the same water when it reaches to the point B, that means the consumption point, and if you do the water quality analysis in both the points, it should be absolutely same. So that part also is very much important. Fine. Next is the cost of the pipe. So considering or the satisfying the above parameters, next important thing is we need to say, cost. How much cost is going to be consumed during the overall construction process. See, there might be two different materials which are satisfying all the points which we have discussed before, but then one is much more costlier than the another one. So that part is also very much important. And at the same time, maintenance of some material will be much more difficult compared to some others. So that part again converges to the fact that that will affect significantly the cost of the construction as well as the cost of the pipes. The frictional head loss should be minimum, so we'll be discussing in detail about this, because this frictional head loss tend to change significantly the overall design parameters of those pipes. So we'll be discussing them in details, and we'll have to keep in our mind that the frictional head loss would be minimum, to increase the overall efficiency in the distribution. And the damaged units should be replaced or easily, or repaired easily. So I mentioned this point before in a different term, that maintenance has to be easier when we talk about a particular type of a particular type of material which can be utilized as the pipe or the pressure conduits. Now the important thing is we should know what are the different type of pipes which are usually used in case of water supply system. So we have cast iron pipes. That's the most available one, and predominantly being used throughout the since long. I mean, it's pretty much old utilization of cast iron pipes. So next is the steel pipes. Fine. And then comes your pre-stressed concrete pipes. This is also another one important, I would say, type of pipe, but this is very state of the art. Earlier days these pipes were not there. Next is RCC pipes, so that is the conventional reinforced cement concrete pipes. Then comes asbestos cement pipes, AC pipes, galvanized iron pipes, and then we have the PVC and plastic pipes, which are becoming, which are gaining a lot of popularity these days, and you will see mostly these kind of pipes. Apart from that, we have wrought iron pipes, and we have steel pipes. We have copper pipes. So these are the pipes which are obsolete these days, but it used to exist some time back as well. So now, if you see, mostly these are the 7 different types of pipes which are available in the market, and which are, and the scale of utilizing a particular type of pipes is different. In some places you will see that utilization of RCC pipes would be huge. In some places GI pipes would be huge. In some cases PVC pipe or plastic pipes will be huge. So that depends again. So we'll now talk about the different advantages and disadvantages of different type of pipes. So cast iron pipes are used in great majority of water in distribution mains, because of centuries of satisfactory experience. So distribution main is the main tributary from where all those branch are actually going. So the distribution main is the main pipelines, and it has been observed that the durability of such pipes are huge and very satisfactory, and that is why it is always preferred. And and it live maybe more than 100 years, and that has been observed from the practical view. So cast iron pipes are resistant to corrosion, and that is the reason it has very high longevity or durability. And their cost is moderate, is not huge. So in short, we say CI pipes. Like GI pipes, we have CI pipes. So their jointing is very pretty much easier. And then they are resistant to corrosion, so it is not very easy to get them corroded, and they have usually very long life. So 100 years is huge. When you are planning a water supply scheme, all the other design components may have 30 years, 40 years, whereas this CI pipes will have a life of 100 years. Now, in each and every type of pipes which we are going to discuss, they would have some inherent advantages and as well as disadvantages. Now we are going to talk about that now. The main disadvantage is, these pipes are once you take a bigger CI pipes, there is a chance of breakage of that pipe, and this can be considered as disadvantage if not handled properly. Bigger or larger dia pipes can break. Next is they are subject to tuberculation in certain waters, due to which their carrying capacity is reduced to as much as 70%. Fine. So this is a very practical problem. So what happens is the deposition happens within the pipe, and thereby it reduces the overall diameter of the pipe. They are heavier and hence uneconomical when their diameter is more than 120 centimeters. So this is also a very important point to remember. And they cannot be used when the pressure is greater than 0.7 Newton per millimeter square. So if you have more than that, then these type of pipes are not they are not going to sustain that huge pressure. So these pipes are fragile, I would say. They easily break. So that's the part we should be keeping in our mind. So when you choose a particular type of pipe, so these are the different factors which you need to analyze, and then you have to come with the most suitable one for your conditions. So we'll go and discuss about the next type, that is the steel pipes. So steel pipes are, in this case, the number of joinings are less, and they are available in longer lengths. Fine. Because the chance of breaking is very less in this case. These pipes are cheap in fast cost, so initially the installation cost will be lesser, since the pipes will be cheaper compared to the CI pipes which we discussed before. These pipes are durable, and steels are having this property of durable property of durability, and which actually stands for this case also now. And they are flexible, so they can be laid in curves. This is also very important part, and this advantage is not there at all in case of CI pipes. And transportation is very easy because they are lightweight, they are not going to break, and they are flexible, so it is always easier to transport them. Whereas the maintenance of steel pipe is expensive, and this is the main drawback of this kind of pipes. Now the pipes are likely to be rusted by acidic or alkaline water, so it's another one problem. So these are vulnerable to the reaction. These pipes require more time for repairs during the breakdown, and hence not suitable for distribution pipes, because you would take a certain type of pipe which takes less time for the maintenance, because they would be in a system where you need 24 hours distribution in most of the time. Now we have discussed that intermediate systems also exist, but then still people work in the daytime or in the office time, so That's the main problem. You have to stop the distribution system in that particular area, and then you will have to start working there. So it's that from that point of view, it is difficult, and the pipes may deform in shape, under combined action of external forces. So this is very interesting. These are light, so the wall thickness is lesser, and they are flexible. That is the reason. But at the same time, once they are they are exposed to some external stresses, sometimes they can get deformed, so their diameter can get changed. At the same time, they can be completely deformed. So this can be considered as also a very significant disadvantage of steel pipes. Next is pre-stressed pipes. So these pipes, compared to RCC pipe, this pipe can be made smoother. Since you are talking about pre-stressed concrete pipes, so the components are actually casted before you place it in the site. The maintenance cost is low, and see, you can actually connect the advantages of pre-stressed concrete pipes with the pre-stressed concrete itself, and then you will be able to understand or remember more easily. The pipes are durable with life period of 75 years. It has to be, because in case of precast concrete also, pre-stressed concrete also, the durability is, or the life period is more. Now, no danger of rusting, obviously, so there is no metal here in this case, so the chances of rusting is nil. And these pipes do not collapse or fail under normal traffic. So these pipes are actually casted, creating or designing to take care of the load which will be exerted on them. So that is why the chance of collapse is also almost negligible. On the other hand, they have some demerits also. Uh, the pipes are heavy and difficult to transport. Obviously, pre-stressed concrete itself, it's a heavy material, and you are making the pipes, so those pipes are comparatively heavier than if you make a same diameter pipe of some other material. Repair of these pipes are difficult, obviously. Repair would be difficult because pre-stressed, so the components are actually casted before, and on the side they are placed. So repair of a particular components would be very, very difficult. These pipes are likely to crack during the transportation and handling operation, because they are absolutely rigid material. If there is a careless approach or activity while handling them, the chance of getting crack is higher, and then you need to consider them as the damaged one. You cannot use them. So very careful handling is required for this kind of pipes. And there are pipes affected by acids and alkalis and salty. So basically, so if you have water which can have some amount of acids, alkalinity, and the salts, then that can affect the overall quality of the stress concrete pipes, and that can be reacting with the water in long term. That is another one disadvantage. Now coming to RCC pipes. Now in case of RCC pipes, so their durability is same as the stress concrete pipes, and these can be casted at the site itself. So no transportation is required, maintenance cost is less, the problem of corrosion is not there, the inside surface of the pipe can be made smooth, thus reducing the frictional loss. And lasting, another one important advantage is due to their heavy weight, the problem of flotation is not there when they are empty. So that is also very important thing. So the stability can be maintained while water is not passing through, that or during the dry period. this stability can be maintained. On the other hand, transportation is obviously difficult, and in case of RCC pipes, we don't plan to transport it. If we plan, then it's a real difficult task. Now, repair work again, like RCC pre-stressed pipes, repair work will be very, very difficult. Initial cost is high since we are talking about RCC, which you are going to construct, or even if you want to procure it, it will not be lesser than constructing or casting it on the site. These pipes are affected by the acids, alkalis, and salty waters, like which we saw in case of pre-stressed concrete pipes. So similarly, these have the tendency to react with acid alkalis and the salty loads of the water. Next comes asbestos cement pipes. Now they they have very smooth internal surface due to which the frictional loss are reduced, and they are basically manufactured. Asbestos cements are manufactured from the asbestos fiber and then Portland cements, and they are actually combined under pressure to form a dense homogeneous structures, and they have a very strong bond of cement and fiber, and they are completely impervious, and you will see, like, AC pipes in many places. So they are very widely accepted pipe materials or type of pipes, I would say. And so this kind of pipes are light, and joining of these pipes are easy, and they are flexible to do that. They are not prone to corrosion, so the corrosions are less, and they can be easily cut, fit, or jointed. So that part is also very easy in this case. They are light, so easily can be transported. Service connection can be easily taken since they can be easily drilled and tapped. So that is very good, advantage, I would say. So if you have, after 10 years, if you want to increase the number of consumption points, so that part can be done from this kind of asbestos cement pipes easily, and they are not at all prone to corrosions. So these are the advantages. Whereas these pipes are brittle, and therefore handling is really, really difficult, and they are very weak under impact loading due to moving traffic. So they will simply collapse, and this kind of scenario you might have observed many times. So that means they have a problem in durability. So that part is very important. These pipes cannot be laid in the exposed place. Again, there will be a chance of impact loading, and immediately it will collapse. Now the pipes can be used only for very low pressures. Now if the pressure is high, internal pressure as well as that external pressure, these pipes cannot sustain that much pressure. So you have to see how much would be the expected pressure which may exert on the pipe. And if it is less, then only AC pipes are prescribed, otherwise not. So the next immediate one is galvanized one, GI pipes. So GI pipes are comparatively cheaper. They are lightweight and easy to handle, and these pipes are easy to join as well. So these are the advantages with galvanized iron pipes. And the, apart from that, if we talk about disadvantage, so again, their reactivity with the alkalinity or acidic water is quite alarming, and the life of these GI pipes are not more compared to the RCC pipes or what we discussed before. This is significantly lesser, 7 to 10 years, and that is why it's not that suitable. If you have a pipes, if you want to lay the pipe, and then it has a lesser life compared to the other components, so then it is not quite economically feasible to use them as distribution main. However, in several components we can use galvanized iron pipe because of its inherent advantages. And then finally the PVC pipes. Now PVC pipes, most of you have seen, most of you have observed it properly. So they are cheap, durable, flexible, free from corrosion. So they electric energy cannot pass through them. They are lightweight, can be transported easily, and they are not easily breakable. So these are the important advantages with the PVC pipes. Now, on the other hand, the expansion coefficient is higher, so that's why this PVC pipe can get expanded if there is a slight difference in the temperature. It is difficult to obtain the plastic pipes of uniform composition. Yeah, so that's a problem. So they are not weather proof, which we say. Uh, if the temperature is higher, so the water through water which is actually passing through these pipes will also be hot. So they are less resistance to heat, I would say. And sometimes some types of plastic impart taste of the water. So that's another one problem. You might have observed that if you buy a low quality pipes, and if you connect it with your water to take out that water, now once you take out that water, you will see that there are some smell or some uh, typical plastic smell or stinking is coming out. So these are the disadvantage of this PVC pipe. However, these days PVC pipes are being used in huge scale, because of its advantages. So now, so before going into laying and testing, let me talk about a bit on the design aspect. So, you know, the, in this case, mostly, the hydraulic gradient, as I mentioned, for pressure pipe, should be such that it, such as to generate velocities which are neither too small or not. It's not too high, because we need to see that water is not getting stagnant. Then there will be a problem of siltation. If it is very high, then that extra pressure would create a problem to the material. So and at the same time there will be excessive loss of pressure head due to friction. So that is why the velocity should also be non-silting or non-scouring. So this is very important. And so the flow velocities are normally kept between zero point 0.9 meter per second to 1.5 meter per second. Fine. 0.9 meter per second, 1.5 meter per second. This is the velocity which are maintained within these pressure conduits or pipes. Fine. Though this is not the maximum limit, the velocity up to 3 meter per second to 6 meter per second, and the resultant pressure can be registered by the pipe materials. However, to be in the conservative sides, the range is taken as 0.9 meter to 1.5 meter. And it is normal practice to design these pipes in such a way that the available pressure head between the source and the city is just lost in overcoming the frictional resistance offered to the flow by the pipe interior. Now, the main loss or head loss happens because of the friction, pipe friction. Apart from that, there might be some minor losses because of the abrupt changes the flow, because of the geometry, pipe size bends, and valves or other appurtenances which are fitted with the distribution system. However, in long pipes, which are basically used for conveying water from the source to the distribution or consumption point, the minor losses are actually so less compared to the head loss due to friction, we often can neglect them. So the head loss is actually what we are going to discuss. Fine. So mostly, if you see, there are four important formula which are used to calculate the they calculate the head loss due to friction. Now the first one is Darcy Weisbach formula. So this is the most popular one and is most widely used. And so this formula is actually performing very well as far as design is concerned for more than 100 years. So since last 100 years, it is actually being utilized to calculate the overall head loss. You see, and this formula states that HL, that is the head loss in meters, equals to F dash capital L by D into V square by 2G. So you can see all the connotations are given over here. L is the length of the pipe in meters, small d is the diameter. V is the mean velocity of flow through the pipes in meter per second, so that can be taken as 0.9 to 1.5 meter per second, which I mentioned before. G is the acceleration due to gravity, and F dash is very important. So just try to understand this. This is a dimensionless friction factor, and this is varying from 0.02 to 0.075, and this actually changes depending on the roughness coefficient of the inner surface of the pipes, and it depends on the Reynolds number. So the relative roughness of the and the relative roughness of the pipe, as I mentioned. So the relative roughness again is calculated as 2E by D. It is given over here, and of a pipe depends upon the absolute roughness. So absolute roughness is again denoted as small e here, and that is the absolute roughness of the inside surface. And the diameter of the pipe is d, and the approximate values of f dash are given in empirical relationship. You can see in the right hand side I have mentioned them. So for old pipes and for new pipes, we have two different formulas, and based on what type of pipes we are using, we can take any one of them. And the accurate value of f dash depends upon, as I mentioned before, the Reynolds number and the delta, that is the relative roughness, right? So again, relative roughness is basically that depends upon absolute roughness. So these are the two important factors we will be considering, and the formula can be given over here is equal to f dash equals to a plus b by r e to the power m, where a, b, and m are constant. Now, for different conditions, we can take different RE value, and accordingly we'll get the value of A. For laminar flows, the RE value is taken as 2000, so you will get a if dash for that particular value. Now, for turbulent, when the RE is more than 4000, now in that case we have to take, for smooth pipe and rough pipes, we have two different formula, and you can take it, and accordingly you will be able to calculate the value of f dash. For smooth pipes and the RE varying from 2000 to 20 lakhs, the Slitcher has given the formula, so that formula is also given here. You can see f dash equals to, so 6.8 we have shown that formula. Now Nikuradse has given for smooth pipes when RE varying from 20,000 to 34 lakh 40,000. So this design of pressure conduits is generally governed under this equation, as the flow of water through the pressure conduits is usually turbulent. So that is the way we can calculate the value of HL. Now the main factor which is our concern over here is f dash, how to get the correct value of f dash, and there are several ways by which we can get the value of f dash here. Now in critical zone between 2000 to 4000, that's the most critical zone, both RE and 2E by D make their appearance, and this relation suggests, this relationship was given by Colebrook and White, and I have given in 6.10. You can see that. So for this, the values of E, that means 2E, that can be taken from the table which is given in 6.1, and accordingly you should be able to calculate f dash, thereby you should be able to calculate the HL. Fine. Now this Darcy West dash formula, though it is very old, as I mentioned before, more than 100 years people are using this formula, is not generally preferred by water engineers in solving the routine fluid transport problems encountered in water transmission lines and pipe networks, mainly because of the uncertain values of 2E by D and f dash. So the getting correct f dash is really a big challenge. Even if E is known, D is not pre-known. So D is basically, you are going to design that. So a trial and error solution will therefore be required, making it complicated. And that is the reason these days people, designers are not preferring, despite of being that fact that this particular formula is being used for the last 100 years. So that means we have a better, substitution of this particular formula. So let's see, and we are going to talk about now about Manning's formula. So in Manning's formula, though generally used for gravity conduits, is also applicable to turbulent flow in pressure conduits, and it has been observed that this Manning formula yields a very satisfactory result provided the roughness coefficient eta or n, and that has to be measured very accurately. Now the overall accuracy of the Manning formula depends on how accurately we are estimating or predicting the value of n. So the formula is given over here, HL equals to n square V square L by R to the power 4 by 3. So n is the Manning's rugosity coefficient, you might have heard before. Rest of the parameters are known to you. Hydraulic mean depth is the capital R, so that is also known to you. I guess all of you should be able to remember what you have studied in fluid mechanics. And in this formula, this formula is used in water supplies pipes and as well as sewage pipelines also while designing the sewer. So this is a very good substitute of the Darcy Weisbach which we discussed before. Fine. Now another one, as I mentioned, that is the Huygens-Williams formula. So this is the number 3. So Huygens-Williams formula is the number 3, and this formula is very widely used for pipe flows. There are very good substitutes, and I would say of the past which we discussed, Darcy and Weisbach, and Manning's can also be used, as well as this Huygens-Williams are also being used these days. And this formula states that V equals to 0.85 CH/R, capital R to the power 0.63, S to the power 0.54. Again, here you have that CH, which is coefficient of hydraulic capacity, and this can be taken from the table which I have given in the 6.2. So that value is now available. Now we'll have to see the other one. So hydraulic mean depth is the capital R, that can be calculated or can be obtained. Next is the S. S is the slope of the energy line, that has to be calculated or that has to be obtained very carefully, and V is the flow velocity through the pipe in meter per second. Now the carrying capacities of pipe decreases with time. So that means the properties are getting dynamic, and because with the passage of time their surface go on becoming more and more rough, and because of that the carrying capacity would decrease with time. Hence, it is customary to select higher values of E and N and lower values of CH for old pipes than are generally taken for new. So in order to accommodate this fact that with respect to time the carrying capacity would be reduced, such kind of arrangements are done. For E and N you take the higher values, for CH you take the lower values to accommodate that fact. Fine. Apart from that, we have the modified Huygens, which I am not discussing here, since in your syllabus this is not there. So we'll discuss these 3. But however, I will suggest all of you to go through this as well, modified Huygens-Williams formula, and only a slight modification is there in this one. And not only in this case, I am discussing here in this particular class about based on the syllabus which is given in the institute curriculum. But there are several important things which you need to cover if you are planning to sit for competitive exams. So what I would suggest you is, apart from seeing the course curriculum and syllabus of this particular paper, you just try to see the syllabus of the competitive exam and just try to get the difference in the subject as far as topic is concerned, and those topic you should study by yourself. And if there is a problem, you can always discuss with me. I'll be there always to help you. So now I'll stop over here, and in the next class we'll be discussing the pumps. So that is another one very important components of the distribution system. There are few, numerical problems which we'll be discussing subsequently if time permits. Otherwise, also what you should do is the way you should prepare is, you just solve the problems from any textbook which are given as example, and once you are accustomed with that, and you can understand how these formulas and how these different parameters are obtained, then you go to any competitive exam books and try to gather all the questions from there, and then try to solve those problems. Now once you study this, if you do that practice, things will be ready from your end. So later on, you just go through your copy and you will be ready to sit for that particular competitive exam. So this is the strategy you all should follow, and you should practice, because you see all sorts of problems which usually come in the competitive exam cannot be covered in this during the class hours. So I will discuss few problems, a few example problems which are conventional, and like design problems where you can utilize all the parameters and components. But most of the time, you will see some uh, different type of questions coming in the competitive exam. So you gather those questions. It is your responsibility and try to solve them. If you are having any problem, you can send it to me and I'll work upon that. Fine. So with this, I'll stop today's class.